Greetings, AP Calculus students, to another day in our review for the AP Calculus exam. With another day, we have another free response question to go over. Let's get to our warm-up first, and then we'll get to the free response question. So here we have a relation sine of xy equaling y, then dy dx is equal to blank. So this is asking us to find the derivative of y with respect to x, given this implicit relationship in terms of x and y. So since this is an implicit relationship, we are going to be using implicit differentiation to find this derivative. So let's do it. So as you'll see, remember, implicit differentiation still uses the same rules, power rules, product rules, so on and so forth. There's just this added term when we do it of having that dy dx term as a result of our differentiation along the way. So that's the only thing we have to be wary of. So we have the sine of xy. So let's find the derivative of that. So the derivative of sine of xy is just cosine, right? The derivative of sine is just cosine of xy. Now this is where we have to use the chain rule. So we have to multiply by the derivative of the inside, which is xy. So to find the derivative of xy, we have to do the product rule. To find the derivative of xy, we have to do the product rule. So let's do the product rule. And let me actually do this off to the side here. So the derivative in terms of x of xy. So that gives us, so we do the first function, which is x, times the derivative of y, which is just dy dx, plus the second function, y, times the derivative of the first function, which is just 1, since the derivative of x is just 1. So it looks like our derivative of the inside is just x times dy dx plus y times 1, so just y. So there you go. So cosine, outside function, times the derivative of the inside function. And in our case, the derivative of the inside function required a product rule to evaluate. And now the other side, the derivative of y, is just dy dx. So nothing too complicated there. All right. So recall, in situations like this where we have to do implicit differentiation, it's recommended that you get the dy dx terms on one side of the equation. So to do that, let's first distribute this cosine. So let's distribute this cosine. So we have x dy dx times the cosine of xy plus y times the cosine of xy equaling dy dx. All right, so now we're going to get this term right here to the other side. We're going to get that term to the other side by just subtracting by it. So we're going to have y cosine of xy is equal to dy dx minus x dy dx cosine of xy. So once again, all we did to both sides here is we just took this whole term, we took that whole term and just subtracted both sides by it. So that's why, as you can see here, we have minus x dy over dx cosine of xy. All right, now the reason why we do that, the reason why we get the dy dx terms on both sides is now we're going to factor out a dy dx term. So by doing so, we're left with 1 here, and then x cosine of xy, and there you go. So now we have the dy dx, a singular dy dx. We don't have two of them anymore. Now we can divide both sides by this entire term. So we're going to divide both sides by 1 minus x cosine of xy. So we end up with y cosine of xy all over 1 minus x cosine of xy equaling dy over dx. So we got the dy dx by itself, and we're done. So now we just got to make sure to match up with one of the answer choices, which looks to be answer choice D. Y times cosine of xy all over the quantity 1 minus x times cosine of xy. So there you go. Implicit differentiation. Regardless of what type of implicit relation you have before you, you always want to get that dy dx by itself, which is what we did. All right, so let's look at today's free response question. So this time, Since we finished up the 2019 AP Calculus exam, now we're going to be looking at the 2018 AP Calculus exam, and we're going to be looking at number 2, this time around number 2, which is another calculator question. And as you'll see as we go through this question, it's actually not too difficult of a question. It's not too difficult of a question in terms of the concepts that it covers. The key to the question is being able to use that calculator, And just like previously when I posted those series of tutorial videos covering how to find an integral using a calculator, for this problem I will in the near future, be posting a series of tutorial videos of how to find a derivative using a calculator, because that's going to be the main idea, at least for 2 of the questions in this free response question. So, a particle moves along the x-axis with velocity given by v of t equaling 10 times the sine of 0.4 t squared all over the quantity t squared minus t plus 3 for time 0 less than or equal to t less than or equal to 3.5. The particle is at position x is equal to -5 at time t is equal to 0. So just like previous problems, they give us the initial position of our particle, okay? And that will come into play eventually, so the initial position of our particle. So let's look at part A. Find the acceleration of the particle at time t is equal to 3. Find the acceleration of the particle at time t is equal to 3. All right. Now, hopefully you recall that the acceleration of an object is just the derivative of the velocity of the object. So the acceleration of the object is just the derivative of the velocity. Well, we have the velocity function. So let's find the acceleration of this particle at time t is equal to 3. So this is literally just asking us to take the derivative of our velocity function. So take the derivative of our velocity function. Sorry about that. Take the derivative of our velocity function. So b prime of t at 3. This is where our calculator is going to come in handy. So let's go to our calculator here. So let's see. So the app that I use does allow you to find the derivative at a point. For other calculators, you might have to find, for most calculators, you should be able to do that. For other calculators, you might have x value in. So let's quickly do that. So we have, let's see here. Okay. So we're trying to find the derivative. Actually, let me see here. I know there's that function. There should be calculus. Here, a derivative at a point. That's what I was looking for. Variable x equals 3, first derivative, okay. So there you go. So now I just have to put in the function. So 10 sine 0.4 x squared, since it's x equals 3. So x squared, close parentheses, divided by the quantity x squared minus x plus 3, close parentheses. And there you go. Bam. Gives us our answer. So it is possible to find this derivative by hand, to be honest. It is possible to find this derivative by hand. You would just have to do a very complicated quotient rule. But since this is a calculator question, no point of doing that. Can you? And can you still get the right answer? Yes. But, I mean, we're trying to save some time here. So it looks like our answer is negative 2.118 if we rounded to 3 decimal places. So negative 2.118. So let's go back here. So it looks like our derivative, or our acceleration at t is equal to 3, is 2.118, negative. And let's see, it doesn't tell us to do units, and actually it doesn't even give us units, so that is our answer. So negative 2.118. So simple, really easy as long as you know how to use a calculator to do it. So now B. So B asks us to find the position of the particle at time t is equal to 3. So the position of the particle at time t is equal to 3. Well, the derivative of velocity is acceleration. Now the reverse, the derivative of position, which is they usually use s of t to represent position. So s of t, or it looks like actually in this, we'll use s of t. So the derivative of s of t is equal to the velocity. So the reverse, the antiderivative of velocity, would give us the position. So the antiderivative of velocity would give us position. So that's what we're going to do. We're going to take the antiderivative. Now, we are going to use that initial position. So our position at t is equal to 3, so s of 3 we'll call it, is going to be equal to negative 5 plus the integral from 0 to 3 of v of t. Okay? So negative 5 plus the integral, remember you have to use that initial position, from 0 to 3 of v of t dt. And once again, we're just going to be using a calculator here. Let's get back to our app. Okay, so we have negative 5. So negative 5 plus the integral from 0 to 3 of that entire, let's see, can I put, oh, there you go. That's what I was looking for. 10 sine of 0.4. We'll make it in terms of x squared, but you can leave it in terms of t as well. All right. And then x squared minus x plus 3. Put that x there, and bam. So it looks like our position is negative 1.760. So negative 1.760. And that would be it. That's it. So once again, not bad. Now the only thing you do want to make sure you remember is to take into account the initial position, right? The initial position, or that initial value. We've seen problems where it gave us like the initial, like the starting point, and we do have to take that into account. And once again, if you know how to plug this into a calculator, you have your answer. Simple as that. As you can see, not a lot of work so far for A and B. All right, so now let's look at C. So evaluate the integral from 0 to 3.5 of v of t dt, and evaluate the integral of 0 to 3.5 of the absolute value of v of t dt. Interpret the meaning of each integral in the context of the problem. So it looks like pretty simple. I mean, to evaluate these two, we literally just have to plug them into a calculator. It's just the interpretation part that we'll kind of go back to something that we've learned before. So let's do that first. Let's evaluate these. So the integral of 0, 3.5 v of t dt. So what does that equal? Let's get back to here. So it looks like, well, we already have it in our calculator. Let's just copy that, paste that. Just have to delete the negative 5 part. So it looks like that was 3.240 if we rounded 3 decimal places, so 3.240. So what does this represent? So let's actually do the interpretation part. So without the absolute value, this represents the total displacement of the particle over the interval 0 less than or equal to t less than or equal to 3.5. So in other words, think of this as the change in position. This is the change in position of the particle from 0 to 3.5. So in other words, from 0 to 3.5, this particle has changed its position in the positive direction 3.240 units. So that's without the absolute value bars. Now with the absolute value bars, we get the integral 0 to 3.5. This is something we've talked about before. We've done a free response question dealing with absolute value bars. So let's get back here. So let me see. I should be able to copy this. Let's see how this works. Paste this. But I want that absolute value bar. I think what I have to do here is delete this. I'm going to delete this. Actually, no. Let's see. I should be able to... Give me a second here. There we go. Cut that. Put in absolute value bars. Let's see. Gosh darn it, I forgot where the absolute... Oh, there it is. And then should be able to paste it. Bam. So now I get 3.343. So 3.43... I'm sorry, 3.343. So 3.343. So with the absolute value bars, that represents the total distance traveled by the particle over the interval 0 less than t less than 3.5. Okay, so when you have those absolute value bars, that means you're taking the total distance traveled, because that's the reason why it's total distance traveled is because any movement backwards is still considered distance traveled, right? Any movement backwards, the absolute value bars makes it positive, so it still counts that as distance traveled, because you still walked. If we consider an example where you're still walking that distance. It's just that you're walking backwards in that case, right? So that's why that's total distance traveled. Without the absolute value bars, that's just displacement, okay? So once again, knowing how to use your calculator is important, and then obviously being able to interpret the difference between absolute value bars and no absolute value bars gets you that other point in the problem. All right. So let us see. Gosh darn it. I just realized I made a mistake. Yep. Made a mistake here. I was doing from 0 to 3. Should have been from 0 to 3.5. Copy and paste. Let me down. All right, let's see. Let's just fix this here. All right, so let's see. I just got to... So copy that. Paste that. I forgot that for B, I did it from 0 to 3, not from 0 to 3.5, so 0 to 3.5. Enter. So that's 2.844. So the interpretation is still the same. I just forgot to... I don't want to erase that. So, okay. So is it 2.844? Gosh darn it. 2.844, yeah. So let me put that back there. Nope. Come on. 2.844. And then if we do the other one, you should get, so where's the one with the absolute value bars? Sure to go. Copy that. Paste that. 0.5. So 3.737. All right. So my mistake. I forgot that from the integral that I copied from part B was from 0 to 3, not from 0 to 3.5. So silly mistake. Would have cost me 1 point. Thankfully, only one. Part C is out of 3 points. 2 points is for the interpretations. 1 point is for the answers. So thankfully, since I would have had the interpretations right, I still would have gotten 2 out of 3, but still a bonehead mistake. All right, so now let's look at part D. So a second particle moves along the x-axis with position given by x2 of t is equal to t squared minus t for 0 less than or equal to t less than or equal to 3.5. At what time t are the two particles moving with the same velocity? So this is actually not too bad. So we just have to quickly find the velocity function. Well, the velocity function of this, we'll call it v sub 2, is just the derivative, which is just 2t minus 1. So we literally just have to set these two velocity equations equal to each other and see where they intersect. So where is v sub t equal to v sub 2 of t? So that's literally all we do. And if you recall, the way we would do this on a calculator is we would just graph both equations and then just see where they intersect. So we're going to graph both equations and see where they intersect. So let's quickly do that. All right, here. Let's bring it up. So this time, add, graph. All right. So the first one was 10 sine of 0.4 x squared. Okay, it should be good. And then x squared minus x plus 3. Okay, so that gives me that. And now let's do the other one. So we graph that one. And then this next one is just, was it 2t minus 1? Or 2x minus 1? 2x minus 1. Enter. All right. So it looks like they only intersect at one point, which is convenient. Looks like they only intersect there. So now we've got to find the intersection, which I already put up a video detailing how to find the intersection of two graphs using a calculator. Analyze graph, intersection. So it looks like the intersection is right about there. So it looks like the t value is or in this case x value, 1.571. So 1.571. Okay, so same velocity. At t equals 1.571, I think I remember correctly. Yeah, 1.571. So, as you can see, overall, not a lot of work involved in this problem. A more conceptual and more about knowing how to use your calculator. Okay, so more conceptual, like knowing, for example, in part A, derivative of velocity is acceleration. Knowing in part B, the antiderivative of velocity helps you find position, so on and so forth. So a lot more conceptual, being able to interpret, and a lot more being able to use your calculator. Not a lot of math involved, right? Not a lot of math involved, but more being able to use, or not a lot of computations involved, but more about being able to use your calculator and a couple of concepts. Okay, so hopefully this was not too bad of a problem. Hopefully it was, I think personally, out of all the ones that we've covered so far, probably one of the more easier ones. Okay, so hopefully you tried it out on your own first before looking through the video. Now in terms of our next assignment, which we'll be doing our next class, I will be uploading another free response question handout. Okay, so the handout will be your assignment. So just do that. I think it's just one page. So I think like 4 parts, 1 page. So I want you to try that out for your assignment. It will be extra credit as usual. And sorry, it's 5 parts, A, B, C, D, and E, A, B, C, D, and E. So both those pages, A, B, C, D, and E, it's called Practice FRQ1. So that will be your next assignment. Otherwise, I'll continue to keep you guys updated on any other College Board updates regarding the AP Calculus exam. Hopefully you guys saw the link that I posted to that YouTube channel that's directly from College Board, and they have some good AP Calculus stuff for review. Okay, well, I hope you guys are continuing to stay safe. Otherwise, I hope you guys enjoy the rest of your days. See you later.